welcome back. We are doing the first homework of a Thermodynamics 1 course. The book we're using is Koretsky's Thermodynamics textbook. Homework 1 is associated with chapters 1 and 4. Problem number 6 is actually out of Koretsky, it's 1.28. Now, and as we always do with these kinds of problems, we draw a picture, and we write down what we know, what we don't know, and some assumptions that we can ascertain just by the problem statement. Okay, so we have a rigid container. It has a volume of 1 meter cubed. Okay. It has saturated water. Okay, so that means it's boiling. Okay. H2O. Okay. The pressure is 1 megapascal. Okay. The quality is 0.1. Okay. What is the volume occupied by the vapor? So this part. Okay. So V vapor. Now it doesn't say it doesn't say the specific volume. It doesn't say the molar volume. It says the volume, which is the total volume. Okay. So I've got two things I've got to do here. Okay. So and then okay, my assumptions. Okay, so I'm assuming, because it's rigid, that V total is constant. Okay. There's nothing really else to assume here. Okay, so because everything else is a fact, it's not like I'm assuming it's saturated. That's a fact. Okay. I'm assuming now volume being constant is an assumption because technically that, even if it's a rigid container, it could change volume a little bit. Like maybe on the microscopic molecular level it can, but it's still an assumption. Okay. So, but looking at this, I need to recognize my problem. It's probably a steam table problem because, well, I have steam and I have properties. All right. So what do? I look for my steam tables. So I've gone to my steam tables. The next thing I do is I look for, am I looking at the pressure steam table or the temperature steam table? Okay. It's saturated first. Now, I know it's saturated, but I should check to see if it's saturated. Now, it says it's saturated, and it gives me a quality, so I know it's saturated. So I don't need to check. I just need to go to my pressure table and look up 1 megapascal. I've done that. Now, it's asking about the volume. Okay. Now, it's told me the total volume. Okay. But total volume's not in my table. What is in my table? That's right. I have a specific volume, okay, in my table. Okay. And specific volume has units of, volume per mass. Okay, so if I know the specific volume, I can back calculate the mass. Okay. Is really what I can do. Okay. Now, well, I don't have the volume of the mixture. Now, I do have the specific volume of the liquid, and I have the specific volume of the gas. Okay. So if I look those up at 1 megapascal, let's see here. So this is 0.001127. This one is 0.19444. About the same, but they are different. Okay. But do I know the specific volume of the mixture? No, because it's not saturated liquid, it's not a saturated vapor, it's a saturated mixture. So I have to use that formula to figure out what's the volume. So the volume specific is equal to the difference between the two times the quantity plus the volume of the liquid. Now, again, I'm not going to plug in real numbers, but I'm going to ballpark this. Okay, we got 0.19 minus pretty much, so pretty much I have 0.19 times 0.1, so I have 0.019 plus the liquid, 0.019 plus that is I have about 0.02. Okay, so I have about 0.02 meters cubed per kilogram in the whole mixture. Okay. Well, going back to this formula, okay, that means, so if I rearrange this, the mass is equal to the total volume divided by the specific volume. Okay, so the mass is equal to 1 meter cubed divided by 0.02 meters cubed per kilogram. Okay, so that's 100 divided by 2, so that's about 50 kilograms. Okay, ballparking things. Okay, so I have about 50 kilograms total. Now, I need to find the total volume, and I have a specific volume. Okay, the total volume is related to the specific volume through the mass, but that doesn't tell me the mass of the vapor. It tells me the mass of the system. Okay, so how do I get the volume of the vapor? Or rather, how do I get the mass of the vapor? Yeah, the quality. The quality tells me what percentage is vapor. Okay? It tells me 10% is vapor. Because this is a pure system, it doesn't matter if it's moles or mass or whatever. It's all the same. It counts the same. So 10% of my system is vapor. So all I have to do to get the total volume of my vapor is going to equal my specific volume of my vapor divided by my mass of my vapor. Okay, which is equal to specific volume of the vapor divided by the mass total times the quality. So, which is, 50 times 0.1, and the specific volume of the vapor is about 0.19, and so 0.19 divided by 5 is about 0.04. Meters cubed. So not much. My math looks a little wrong on there, but that number just doesn't seem right for but maybe it is. But it doesn't matter if my math was right or wrong. Okay. What matters is that my process is right. And what is my process? Let's go through it. What's my process? I drew a picture. I wrote down what I knew. I wrote down what I didn't know. I wrote down what I need to find. I wrote down my assumptions. I wrote down all my equations that apply here. Like, pretty much this one, which I did some rearranging. I also used this one. Okay, the one with quality. Okay. And I do those rearrangements, and the final thing that I remembered, after looking up things in the steam table, so and I would write those things down. But after I found things in the steam table, what's the last thing I did? I remembered that quality defines the percentage of, it defines the percentage of vapor in my mixture. And that's, how it's going to tell me.